And from the second subinterval, I'm going to pick another number called x2 star, so on. I'm going to repeat this process up to the last subinterval. I'm going to pick a number here called xn star. Okay. So for example, if I consider here this interval xi, I minus 1, and xi, okay, I'm going to pick a number here called xi star. And for this point, I'm going to pick, I'm just going to take, the point corresponding to this on the curve. So this point, I'm going to call it pi minus 1. So this point corresponds to pi, the x coordinate of pi. So for example, this one going to be my first point. I'm going to call it p0, and so on. Okay. Now, for pi, the coordinates are, as we did yesterday, xi and yi. And since the point is on the curve, yi gonna be f of xi, because the point belongs to the curve. And as you know, if you guys have any point on the curve, there is a connection between the x coordinate and the y coordinate of that point. That's exactly what you have here. The reason why yi equal to f of xi, because this point pi is already on the curve. That's the reason. Now, just keep in mind at the beginning what I said is we just want to rotate this portion of the curve. And what I'm doing here is I'm going to subdivide this curve into small portions, and I'm going to, rotate off these portions. So for example, here, I'm going to rotate the portion of this curve. Okay, just change the color. I'm going to rotate the portion between pi minus 1 and pi. And if I rotate it, I'll get this is really close to a disk. If I rotate it, so I'll get something like that. Okay, and now what I want is to get area. So it means the area, the side area of this disk. That's what I'm trying to calculate. And this disk is obtained from the rotation of the portion of the between pi minus 1 and pi. And to calculate it, I'm gonna approximate the radius. So the radius of this disk is approximately equal to, the radius is approximately equal to or is approximately equal to f at xi star. Just keep in mind xi star is a point from this interval. That's what I did here. This is the radius. Just want to take the red color. So your xi star is here, and this is radius, as you can see, approximately. So it means if you want to calculate the surface area, I'm going to call it d SAI. So this is the surface area obtained from the rotation of the portion joining pi minus 1 and pi. It's very close to a cylinder or a disk, and that's why the is going to be approximately equal to 2 pi times the radius, and the radius is equal to f of xi star. My function is positive, so xi star going to be positive. It's not a big deal. Even if my function is negative, I'm going to take the opposite in order to get a positive. And times the height, and the height is this, is I'm going to call it dsi. And dsi is this the length of the portion is joining pi minus 1 and pi. Okay, so basically we have something like that. We have our disk. And this is your axis for rotation. And this is the radius, which is equal to, this is f of x I star. And this side, the height of your is too small, the height of your disk to dsi. And the volume is given by this equation. Not the volume, the surface area. I mean, the lateral area. Okay, so you guys can see this formula. The portion joining P0 and P1. For the portion joining P1, up to the last portion. And in order to get the total surface area gonna be equal to the sum of these small surface areas. Gonna be the D S A I. I is going from the first portion. The first portion is the portion joining P0 and P1 to the last portion here, N, joining Pn here and Pn minus 1. And this is an approximation of the surface area. Okay, and the details gonna be are present in the next slide. This is just the explanation of what I did in the next slide. Okay, any question before I move to the next slide? All good? All right. The curve. DSI is, as I mentioned at the beginning here, is just, as you can see, your DSI. It joins, the point Pi minus 1 and the point P. And when you join these 2 points, that's exactly what we did yesterday. Calculate the arc length is given by square root of 1 plus the derivative of the function, you square it, times x, and delta x is just the width of the subintervals. That's exactly what we did yesterday. Okay, and delta x in this equation here. Now adding all these elementary volumes, we're going to approximate the total elementary surface area. We're going to approximate the total surface area by considering here n subintervals. So now if you want to get the exact value, so you have to let n going to positive infinity. And when you guys let n going to positive infinity, since my function f is continuous, I'll get, a number, and that number is what we call a definite integral, because this is exactly a Riemann sum based on what we did before. And that number is what we call integral, and the notation going to be integral from a to b by f of x square root of 1 plus f dash. And keep in mind here, we suppose our function f is positive. If your function is negative, you have to add a negative sign in order to make it positive, because what represents your f, as I told you, is obtained from f of xi star, which was, you know, the radius, and the radius should be positive. That's why if your function is negative, you have to make it positive by multiplying it by -1. Okay, so basically when you guys want to calculate the surface area obtained from the rotation of the portion of the curve f when xb is between a and b, is going to be just integral of 2 pi f of x square root of 1 plus f dash u square it, where the axis of rotation is the x-axis. Is it okay?
Yes,
Any
sir.
question? All right. Now let's see the different cases. Okay. Because, you know, the axis of rotation could be sometimes the x-axis or the y-axis. The function could be in terms of x or in terms of y. Okay. All right. So in Leibniz notation, the formula becomes exactly this, because this is, you know, exactly as, you know, the previous formula in Leibniz notation. So we have just expressed our formula in terms of x and y only. That's why. So this y represents your f of x. In the previous formula, this is f of x. And this is, you know, f dash, because it's, you know, if y is equal to f of x, dy by dx is a derivative of y with respect to x, and the other notation is just f dash of x. Okay, it's the exact same formula, but just different writing. As you know, it's the same as, you know, the previous one that we've seen at the end, the bottom of the previous slide. Okay. Now let's see if my function is in terms of x and I change the axis rotation. What's going to happen? Okay, so now if the y-axis is axis of rotation, so we have to modify the formula, because in this case the radius changes. We're rotating the same portion of the curve, only change the axis of rotation. Okay, and you guys I've seen, you know, in the previous at the beginning, I told you what was, you know, so if this is my function and this is a curve that we rotate the portion between a and b. Only if the axis of rotation is the x-axis, you have to formula, because the radius now is approximately equal to this value. Going to be the radius is always the distance from the axis of rotation and this is y, or f of x. Okay, if now my axis of rotation is, if this is now my axis of rotation, so for sure the radius is going to be, as I told you, the gap between the axis of rotation and the curve. So the gap going to be this, but because it's changing, that's why we call it x only, because it's taking from these values here, from a up to b. That's why I call it x. And in this case, you have to use this formula. The y is used when we have this situation. That's the difference. Just keep in mind, in front of the square root, have represent the distance between the axis of rotation and the curve. Okay, so that's why sometimes it's going to be y or x, depending on what is the axis of rotation. And for both cases, you guys can see here, under the square root, it's exactly the same thing. It's dy by dx. The reason is the function is in terms of x. So in these cases, in both cases, we have y equal to f of x. That's why the derivative going to be in terms of x and the integral going to be with respect to x. Because your function here, f, is expressed in terms of x. And as soon as your function is in terms of x, it means under the square root, your derivative should be calculated with respect to x, and the integral should be calculated with respect to x. That's why we'll get dx. Okay? So next case is now my function is in terms of y. Okay, so if my function is in terms of y, we will see in that case what's going to be the when we have x-axis as the axis of rotation or the y-axis. Okay, so next situation, you guys can see the function is in terms of y now, and y is between c and d. It means calculate the derivative with respect to y under the square root because of this, and the integral should be calculated with respect to y when y is going from c to d. So it's going to be integral from c to d in this. Okay, because the function is in terms of y. And the axis of rotation is still equal to the x-axis as this one. So that's why we have the same radius. You guys can see the radius, as I told you, is always the gap between the axis of rotation and the curve. So since, in this case and the last case here, we have the same rotation, that's why we'll get just 2 pi y in both cases. But under the square root, going to be different. Because here in this case, the function is defined in terms of x. That's why the derivative should be calculated with respect to x. And in this situation, the function, as you can see, we have y, we have x equal to g of y. It means my is in terms of y. That's why the derivative should be in terms of y. Same for the integral. The last case now is if I keep, this function as a function in terms of y, but I change my axis to the rotation. So since I change my axis of rotation, so it means now the gap going to be x, as the second case here, and under the square root going to be similar to this case, because in both cases here, the last 2 cases, the function is in terms of y. That's why we have to calculate the derivative and the integral with respect to y. It's okay? All right, so let's see the first
Sir,
example.
it's the same formula. We are just inversing. Instead of writing dy by dx, we're writing dx by dy, right?
Yeah, the
And
reason
the
is
yeah.
here your function is in terms of y. That's why the derivative should be with respect to y. In this case, the function is in terms of x. So for example, in this case, you can get in both cases here, you have y equal to f of x. So here, dy by dx going to be f dash. So for example, it could be y equal to e to the power x, for example. That's what y is a function of x. But in these two cases, we have x is the inverse. X is equal to g of y. So that's why we need to calculate the derivative with respect to y. Because your function is in terms of y, the derivative gonna be should be in terms of calculate with respect to y. So we'll get here, and there's a square root, gonna be g dash of y. And one example is it could be, for example, x equal to y squared minus 2y, for example, plus 7, let's say. See, this is what we mean by x equal to g of y. And this is what we mean by f equal to press. It represents the distance from the axis of rotation and the curve that we're rotating. Is it okay? Hello?
Yes, sir.
All right, thank you. Can I erase this? All right, so next example, we just want to rotate, the curve y equal to x cubed when x is between 0 and 2. Means we rotate the portion of the curve when x is between 0 and 2. And the axis of rotation is the x-axis. So since your function here, how to know, which formula that we have to use. So guys can see here. You see, since your function is in terms of x, that's why your integral gonna be derivative of y with respect to x. So this depends on how your function is defined. And your integral gonna be in terms of x. Okay? This part here, this part come from here because your function is in terms of x. because you have y equal to f of x. Now, inside is going to be 2 pi, always. But the variable here depends on, okay, so we have 0 to 2, because we just rotate the portion of the curve. But here, is it x or y? It depends on the axis of rotation. So if your axis of rotation is x, so it's going to be here y, the opposite. Why? Because if you guess, oops. Because as I told you, if this is your curve, and you rotate only the portion joining these 2 points, okay? If this is your axis of rotation, this is, you know, the values taken by the radius, and exactly equal to y. So that's why in this case is going to be y. Because of this, the axis of rotation here gonna tell us what gonna be here. And don't say it's the x-axis, it's gonna be x here. No, it's gonna be the opposite because of what they represent here, the radius. And we have to use this formula in this case. Okay, just keep in mind the derivative and the dx for the integral depends on how the function is expressed. If it's in terms of x, it's going to be here dy over dx and dx. If the function was in terms of y, you switch, it's going to be dx over dy, and it's going to be dy. Now this term after the 2 pi, it depends on the axis of rotation. Okay. So now let's see how to solve this example. All right, so here is our problem. So our equation is here, and that's what I represent, you know, here in orange. So we rotate the portion when x is between 0 and 2. Okay, and this is our axis of rotation, as you can see. So we're going to be integral from 0 to 2 because we of this, and now to do the calculation, since I'm integrating with respect to x, my function should be expressed in terms of x. And I realize I have a y here. That's why I have to replace it by its value. Its equation is going to be x cubed root of, and you differentiate y, is going to be by using power rule, is going to be 3x squared. And now we're ready to calculate it. Okay. So now I'm going to use just, you know, the substitution rule by setting u equal to 1 plus x to the power 4. In this case, the du going to be 36x cubed dx. I have to find the new interval of integration. When x equal to 0, you substitute here, x by 0, you 1. When x equal to 2, you substitute here. So y going to be, u going to be 145. So now it means my integral going to be from 1. So you guys have to write 1 here. So from 1 to 145, 2 pi, and I replace here by root of u. And where is the x cube here? X cube dx, from this equation you guys can see, x cube dx is equal to du over 36. That's what I got here. So from this equation, so you can see du over 36 is equal to x cubed dx. And I just represent here, replace x cubed and dx to get this part here. And as you know, u root of u is just equal to u to the power half. We're going to use the power rule for integral. Is it okay up to here? All right. So just keep in mind, as I said, u equal to u to the power half. You use the power rule for integral, going to be 2 by 3 u to the power 3 by 2. And by using the FTC, this bracket is obtained when you substitute u by 145. And the second term, you just substitute u by 1. Okay. And I'm going to take 2 by 3 out because it's a common factor, 2 by 3. And I'm going to factor out is going to be 4 and 30, 60 times 3. I simplify, it's going to be just 2 pi over 54. Okay, because here I just simplify 1, 2 here, and 38 is just equal to 18. Okay, going to be just 2 times 18, and 3 times 18 going to be 54. Okay, and after calculation here, the denominator going to be 27 because I simplify here 2 pi over 54. We can simplify by 2. It becomes just pi over 27. That's exactly what I got here. So since it's a surface area, it's going to be in unit square. Any question? All right. So you guys are done? Hello? Are you done before I move to the next page?
Yes, sir.
Yeah? Angabet, what did you say?
He said no, I think.
Okay, so let me know whenever you're done.
Sir,
Yeah.
go.
No, because it's x cubed dx which is equal to du by 36 from here.
But isn't it supposed to be du over 36x cubed?
No, so just let me show you. this, you can see du from there over 36 is equal to x cubed dx, right?
Yeah.
Okay, and you see here, you have your x cubed and your dx here. So it means the x cubed and dx, you combine them, you replace by du over 36.
Yeah, I got it. Thank you.
Well, so let me know whenever you're done.
Sir,
Yeah.
can you explain again the after du divided by 36?
So from here,
Yeah.
okay, so what I did is I took, this is a constant 2 pi, I took it out. And also same for 36 is going to be over 36. I get integral, so here it's from 0, from 1, because of this, and we integral from 1 to 145. But root of u is just equal to u to the power half. Is it okay? And when you calculate the integral, so you guys, you just use the power rule, when you calculate integral of x to the power n dx. Okay, so this is equal to x to the power n plus 1 over n plus 1. That's what I use. So this integral here, n is equal to 1 by 2, is going to be u to the power 1 by 2 plus 1 over 1 by 2 plus 1. Just applying this. Okay, and this is equal to u to the power 3 by 2 over 3 by 2. But dividing by 3 by 2 is exactly equal to multiplying by the inverse of 3 by 2, going to be 2 by 3. U to the power 3 by 2. And that's exactly what we use here. Is it okay?
Yeah.
So this is just what they call the power rule for integral. That's what I use. Any question? And just keep in mind now, 145, for example, to the power 3/2. Okay. This is just equal to 145 to the power half to the power 3. And this is equal to root of 145 to the power 3. And this is equal to root of 45 square times root of 145. Okay, it's the square times the root of going to be power 3. And this is just equal to 145. So that's what we got here. From this step. So this step is obtained from this calculation here. Is it okay? Any question? So you guys are done?
Yes, sir.
All right. So let's see the next example. All right, example number 2. Now we still have the same axis of rotation as the previous example, which is, the x-axis. But here the function is defined in terms of y. And if the function is defined in terms of y, keep in mind your integral. In order just to find the appropriate, formula, since your function is in terms of y, as you can see, and here your integral should be in terms of y because you have the integral. So it means you have integral and should be in terms of y because of the y here. This is, what I said before, x equal to g of y. And under the square root, it should be 1 plus, since it's in terms of y, it means my derivative should be in terms of y here. It's going to be dy bottom because my function is in terms of y. Okay, so this part here and this one are from here. Now you have 2 pi, and since we still have the same axis of rotation as the previous one, is going to be just y, like the first one. But here you don't have to substitute y by anything, like this example. This case we did it because we had to express our integral in terms of x. So here we don't have to. The reason is of the dy here. It means my integral should be in terms of y. So since I already have the y, I just leave it like that. Okay, this is how to find the appropriate formula. All right, now let's see how to solve it. So as I told you, since my function is in terms of y, it means my derivative should be with respect to y, and my integral should be in respect to y. And since my x-axis is axis of rotation is x-axis, so it means it's going to be here y. And to apply the formula now, I don't have to change anything for y because I already have y, and my integral should be in terms of y. And I'm going to calculate the derivative of this function with respect to y. And to differentiate it, I have to use chain rule twice. We have 1/3, and the exponent 3/2 becomes the coefficients, and the new exponent going to be 3/2 minus 1 as the power rule says. And times, as a chain rule, the derivative of this, which is equal to 2y, and you square it. So next step, I'm going to simplify here 2 and 2, and simplify here 3. It remains only y and the bracket here. And to the power 2 is going to be just y squared. And here, since it's the exponent 1/2, you square it, it becomes just, and now you have to multiply y squared and this bracket. Is it okay up to here? And just keep in mind here the power half vanishes because of we have power 1/2, you square it, it's gonna be power 1, and you have this y squared. That's why we have here y squared. And you guys can realize this is a square, in fact, because you have y to the power 4 plus 2y squared plus 1. And you guys can see this is just a squared plus 2ab plus b squared. So it means I'll get just my a gonna be y squared and b gonna be 1. So that's what I use here, because I realize this is a square, as I told you, is going to be just y squared plus 1. So square root of this square going to be just, y squared plus 1, since it's already positive. And now I'm going to expand this bracket here. I'm going to just, open it. Going to be y times y squared, going to be y cubed, and we'll get just y. Again, we're going to apply the power rule that I mentioned before. So we'll get here y cubed plus y, and it becomes 1/4 y to the power 4. For the second term, it's going to be y squared over 2. And this first bracket is obtained when you substitute here y/2. Because when you substitute here y/2, it's going to be 16. 1/4 times 16 is going to be 4. And when you substitute here by 2, it's going to be 4/2, which is equal to 2. So the second bracket here is obtained when you substitute y/1. And after calculation, we'll get 42 pi by 4 units squared. So we can simplify by 2. And it's going to be 21 pi by 2. So you let me know whenever you're done. All good?
Sir, could you please zoom out?
When I see the top,
Yeah.
is okay? So one more example. All right, so we did one example where, you know, the function is in terms of x, and another one where the function is in terms of y. And for both of them, you know, the x-axis is the axis of rotation. So next, I'm going to take an example where the axis of rotation now is a y-axis, and my function is in terms of x. Okay, so since my function is in terms of x, it means my integral should be with respect to x. Same for the derivative under the square root. It should be in terms of x, means dy by dx, should be with respect to x. So now, so we have y equal to 1 minus x squared for x between 0 and 1. And your rotation now is the y-axis. Okay, so this is just a parabola. I'm just gonna sketch it. You guys can see. Quite easy. And since the coefficient of x squared is negative, it means the parabola is up and down. And at 0, let's say it's a 1. And when x equal to 1 here is going to be 0. And we just rotate the portion of this curve, only this part. I will not draw the other part. We only, you know, rotate because x is between 0 and 1 as the question mentioned here. And you rotate it about, we just rotate the curve, not the area, because when the area, so you will get a volume. So when you rotate the curve, you will get a surface area. Okay. So when you rotate this, so you will get the and the axis of rotation now going to be is the y-axis. It means this is your radius. And this now, what is it? It's x, because if you pick any point here on D, it's going to be x here. So that's why you have to use, because as I told you, your the variable in front of the square root is always the radius, and it's given by the distance. Now, when we apply the formula, right here, and I'm going to equal to 1 plus, I'm just going to erase this. So make zoom, we zoom out. It's okay. Now I set here u equal to 1 plus 4x u squared, and the do u gonna be derivative of 4x squared gonna be 8x times dx. And from here you guys can see x times dx is equal to du over 8. And now we're gonna find the new limit for the integral after using the substitution formula. So for x equal to 0, you here it means y is equal to 1. And for x equal to 1, so you will get just 4 plus 1, u equal to 5. Now my integral gonna be integral from 1 to 5. You just substitute here, u is gonna be root of u. But x by using the power rule, as I mentioned before. So we'll get this. And use the FTC now. So when we use the FTC, substitute u by 5 first to get this term. Okay, I already took here this 2 by 3 out. When you simplify, it's going to be just pi over 2 times 1 over 3, going to be just pi over 6. And this term is obtained when you substitute u by 5. The second term when you substitute u by 1. And we'll get the solution. As is known, this is just equal to 5 root 5. And exactly what I did for 145 to the power 3 by 2. If you use it again here, so you guys will get 5. Any question? So you guys are done?
Yes, sir.
All right. All right, so next we'll see the same problem when we rotate, in this case, the a parametric curve. Okay, so we suppose here we have a parametric and by these two equations, x equal to f of t and g equal to, y equal to g of t. And we only rotate the portion of the curve when t is between alpha and beta. And when you rotate it about the x-axis, we guys have just to use exactly the previous formula. It's going to be 2 pi y because the axis rotation is the x-axis. And based on what we did yesterday, you can't. We know this is just obtained from, is exactly equal to square root of 1 plus dy over dx. It's the same thing. It means if you use the previous formula, you'll get the same thing. But this is just to simplify and adapt it to this situation when you have just a parametric curve. So this part is, this is exactly, you know, the same formula, except here we have to do our integral with respect to t because x and y depends on t, not x. x and y depends on t. That's why you have to integrate with respect to t. And when it comes time to do the calculation, you guys have to replace here y by its equation. Okay. When it comes time to the calculation, since you integrate respect to t, this function should be in terms of t, and under the square root, when it comes to the derivative, you will get the function in terms of t. That's why you have to substitute y by its equation. And we have the same situation now if we change the axis of rotation. So as I told you, when you change the axis of rotation, you need to change the radius. Instead of y is going to be x now. And for this case too, when you do the calculation, you have to substitute here. You substitute x by its equation in order to express the integrand in terms of t only. And you calculate it. And as I mentioned before, this is just coming from plus dy over dt squared. All good? All right, so let's see an example. All right, so here is our example. Our axis of rotation is x-axis, and we have x equal to t cube and y equal to, this is my g of t, and we rotate the portion of the curve when t is between 0 and 1. All right, so now we'll get the axis of rotation is the x-axis. That's why we'll get here 2 pi y, and under the square root, we have to differentiate these two functions with respect to t. So I'm going to take here 2 pi out of because it's a constant, and I'm going to substitute here y by its value. So y is equal to t squared, as you can see from the top. That's what I did here. And under the square root, I'm going to calculate dx by dt, which is a and when we drop the bracket, it becomes 9 t to the power 4, and here it becomes 4t squared. And you guys can see here t squared is a common factor, so you can take t squared out of the square root. When you take t squared out, it becomes only t. you multiply it by t squared, it becomes a t cubed. And after taking, t squared out, the first term now becomes a 9t squared, and the second term becomes a 4.
Excuse me, sir.
Yeah.
Sir, when we're taking t square as common from 9t to the power 4 and 4t square, shouldn't be t to the power 4 instead of t cube?
Now you take it out, it becomes only t. You take it t square out of the square root.
Oh, okay, sir. I got it. Thank you.
You're welcome. It was t square, but you take it out of the square root, it becomes only t. You multiply by t squared. Is okay? All right, so next I'm going to use again the substitution rule. And if I want from here, I can use also, the trig substitution, but it's going to be more complicated because under the square root, you have the sum of two squares. We can use also, the trig substitution. But it's going to be easier to use this substitution. So u equal to 9t squared plus 4, your du going to be 18t because you differentiate this part. Going to be 18t times dt. And when t equal to 0, you're going to be 4. You substitute here t by 0 to get the new interval of integration. That's why you have to do it. And when t equal to 1 from the second endpoint, t equal to 1, you substitute here, it's going to be just 9 plus 4, you get 13. Now my integral going to be from 1 to 13. So from this step here, I just substitute. I'll get 2 pi integral from 4 to 13. I still have my t cube, and here I have root of u. And the dt, we can get it from here. So dt gonna be du over 18t. So you substitute here the dt by its value. And we simplify t. So we simplify here 1t. Just want to change it. So we simplify t here and 1t here. It becomes now t squared. Right? And t squared, you guys can get it from here. Because you integrate respect to u. That's why you have to replace t squared by its value. So from here, you guys can see t squared is equal to u minus 4 over 9. And I replace t squared by its value. That's what I got here. This. And I took here the 18 out to get here 2 pi over 18.
Is that t square or cube?
It was t cube. You simplify with this t.
Oh.
It becomes a t square now. It was t cube, as you can see from this step. Now this t cube, and we have 1t coming from the dt from here. So from this step, you guys can see dt is equal to du over 18t. I just substitute the dt by du over 18t, and I simplify 1t here and 1t, it becomes now t squared. And t squared, we can get its value from here in terms of and express it, in terms of u. Sounds good? Is it okay?
Yes, sir.
All right. Okay, so next step, I'm going to open this bracket here. Just keep in mind the root u is equal to u to the power half. And u to the power half times this u is going to be u to the power 3 by 2. And u to the power half times 4 is going to be 4u to the power half. And before that, I just simplify here by 2 first. So you simplify here by 2, it becomes 9. And I took out this 9, multiply it here. That's why it becomes 81. Okay. And I just, expand this part here to get this integral. Now I have a power functions. So I can just, use a power rule. So 2 by 18 becomes just 1 by 9. And the other 9, it becomes 81.
Sir, could you please zoom out?
Yeah. All good?
Yes, sir.
All right. Now, next step, we're gonna just, integrate by using the power rule that we've seen, at the beginning. So it was, u to the power 3 by 2. It becomes, u to the power 5 by 2 over 5 by 2. And dividing by 5 by 2 becomes, multiplying by 2 over 5. And if you remember, it was here equation 4. You multiply by 2 over 3, it becomes 8 by 3. And the first bracket here is obtained when you substitute, u by 13. The second bracket when you substitute, u by 4. And as we did, for 145, so here when you calculate, 15 to the power 5 by 2 is just equal to root 15 to the power 5, which is equal to, so we just multiply by 2, it becomes 338 root of 13. So now I'm going to calculate the common denominator. So I multiply this 3 by 338 root 13, it becomes 1014. and 5 times 104 is going to be 520. And the common denominator now is 15. And from the second bracket, when you calculate it, so you'll get just 128 over 15. Is there any question? So you guys are done?
Yes, sir.
All right, so this is our last example today, and this concludes this chapter. And as I told you yesterday, in our next class next week, so we're gonna do some review questions coming from past final exams. Okay. Suppose some of the question this weekend, so you guys try to solve as much as possible, and then in our next class you can tell me the question that you found challenging, and then if you need more explanation, so I'm here for that. Is there any other question? All right, so that's all for today. And before letting you go, I'm just going to take the attendance, please. All right, so Magabet. Magabet. All right, thank you. Fatima,
Here.
thank you. Alamin.